Good day, students. On this clip, we're going to be going over the STAAR Algebra 2 release questions to get you ready for the state test. All right, so let's start out by taking a look at number one. It says the graph of G was obtained from the graph of the function f using the transformation as shown above. Based on the graph, which equation can be used to describe g of x in terms of f of x? Now, there are four possible types of shifts that you can have. Is there shift up or down, or shift to the left or to the right? So let's say you have an original function f of x. If you have a function f of x, if you have any addition or subtraction to the x that results in a movement along the x-axis. So if you have f of x minus a, this minus basically means you're going to do the opposite. That means you're going to go a units to the right. Okay? If you have x plus a, you have a units to the right. If you have f of x plus a, since you're adding directly to the x, it's going to be a units to the left. Alright? So when it comes to left and right movement, you do the opposite of whatever the sign is. So if you have a plus, you go to the left. If you have a minus, you go to the right by the number of units that you have next to the sign. Now you have f of x plus a. This one you actually follow the sign. Okay, since it's plus a, you're going to go a units to the upwards. And then if you have f of x minus a, in this case you're going to have a units downwards. Alright, so these are the four directions that transformational directions that there are. So let's take a look at this problem. In this problem, this point moved 1, 2, 3, 4, 5, 6. It moves 6 units to the right. So using this guide here, which of the following do you think applies? Moving to the right, this one right here applies, right? So basically, f of x plus 6 minus 6 would be the right choice for this. So in this case, let's see. This one, f of x plus 6, is going to be 6 units up, which is wrong. F of x plus 6 is basically 6 units to the left. That's not what we want. F of x minus 6 means 6 units down. That's not what we want. F of x minus 6 means 6 units to the right. Voila, that's what we want because that's what there is here. Alright, so just remember these rules right here. They'll basically help you to solve problems involving transformation. So the answer to number 1 is D. Alright, so now let's take a look at number 2. It says the graph of the function is shown below, which shows the graph of f inverse. So there are two ways of doing this. One way you can do this is you can draw the line y equals x and make a reflection. So basically draw a line down the center, and the line y equals x goes the other direction. So basically the line y equals x, erase this, it goes this way. And then what you do is you basically try to reflect this line right here along this line. So this line right here will get reflected to somewhere here, like that. And it's going to get reflected somewhere here. And then this line right here will get reflected upwards. So instead of it's going to be sliding somewhere here, and then up, and then over, like that. Okay? So if you have a mirror, and then you reflected this along this line right here is y equals x. If you did that mirror reflection, the resulting reflection is going to be the graph of the inverse of f. So if this is f right here, this is the inverse of f, f to negative 1. So you can clearly see the one that best matches that is this choice right here, choice A. So this is the first way of doing it, just by reflecting along, reflect along the line y equals x. This is a little bit technical, but if you don't want to use that approach, there's another approach that's very safe, not too complicated to do, which is the whole idea of switching coordinates. Alright, so if f has an ordered pair, if f has xy, then the inverse is going to contain the point yx. So all you just do is you just switch the coordinates, and then that tells you how it works. Okay? So let's take a look at this problem real quick. What I'm going to do is we're gonna pick some fixed points, and then we are going to switch the coordinates and see which one will help us, which will give us the answer. All right. So what I'm going to do is I want to pick points that are nice. So I'm going to pick. Wait a minute. Clear this out. I'm going to pick the points that are easy to work with. So I'm going to pick this point right here. What are the coordinates of this point? The coordinates of this point is 1, 6. This point right here, the coordinates is of the end point is 6, -7. All right. So these are the two endpoints for the graph. All right, this is for f, right? So if I want to graph f inverse, this starting point right here, I'll just switch the x's and the y. So f inverse is going to have, so let's make a chart so you can get what I'm trying to say here. So f has a point 1, 6. The inverse is going to have this, what you get when you switch the 2. All right, so 6, 1. So what inverse basically means is that you're switching your output to your input and inputs to your output. All right, so for this one, if f contains 6, -7, that means the inverse is going to contain -7, 6. If I grab these 2 points, then it shouldn't be hard for me to figure out what the answer is. All right, so let me grab the first point, 6, 1. 1, 2, 3, 4, 5, 6, 1. Down. That's 1 point. And 6, 1. That's 1 point. And you can clearly see that this is not an option. It's either this or the other one. And then the ending point is -7, 6. Where is that? -7, 6 right there. So just using these 2 points, this is a start. Sorry about this. This is a start and this is the end. You can clearly see that option A is automatically your answer. So this one doesn't require, this approach doesn't require any fancy reflections or anything of that sort. All right, so these 2 points clearly shows by switching your coordinates that the inverse of f is given by this result right here. Okay. All right, and then when you look at the other ones, you can clearly see that they're not the options that you want. All right, let's move on to question number 3. It says, which of the following represents, okay, so which of the following, given the equation is root of y, x over y equals 4, which of the following represents y in terms of x? So all we are doing here is we're basically isolating, y, and then whatever equation that matches would be the answer, right? So we have the square root of x over y equals 4. So to get rid of y, I need to first of all get rid of the square root, and then address the fact that it's a denominator, and then isolate it, all right? So what is the opposite of square? Root. The opposite of square is square, so I'll do let's square both sides. Alright, since square and squares are inverses, they cancel out. And then you're going to have x over y equals 4 squared, which is 16. Now, this is a fraction. I might as well express this as a fraction too. Now, to eliminate denominators, you can just cross multiply or multiply by the LCD of these two denominators, which is y. So let me just cross multiply, right? Bottom to top, bottom to top. So we're going to have 1 times x, x times 1 equals 16 times y. Alright, so we're going to have x equals 16y. To finish this off, since we need it in terms of y, we just divide both sides by 16. And then your final answer is going to be y equals x over 16. So your final answer for number 3 is C. Okay? Alright, now let's move on to the next example, question number 4. It says, what is the value of y of the solution of the matrix below? So remember, every system of equations can be expressed as a matrix, right? So in order to do this, I'm going to just basically try and express this. I'm going to try and express this matrix as a system of equations, then I'll solve it for y. All right. So how do I express this as a system of equations? Just remember that the first one The first coefficients are the coefficients of the x's, and the second are the coefficients of the y. So when you do your matrix multiplication, you're going to do row times column equals this. So if I do this row times this column, I just distribute, I'm going to end up with 3x plus 2y equals 3. Okay? How on earth did that happen? Well, all I did is I took this 3 and multiplied it by the x, and then I took this 2 and I multiplied it by the y. And then I added them together and made them equal to the top element over there. Alright? To generate the second row, what I'm going to do is I'm going to take this 2 multiplied by the x, and then I'll take this 1 and multiply by the y, and then I'll set it equal to 4. Alright? So your answer is going to be 2x plus y equals 4. Alright, so this is a system of equations that this matrix equation represents. So let's solve this for y. To solve this for y, I can use a method of elimination. I want to just create opposites with my y, and then, I want to create opposites with my x's, and then that will be left with my y. Alright, so how do I eliminate this x's? All I do is I look at the coefficients, which is 3 and 2. I find the LCD and I try to make both of them the LCD. Alright, so what is the LCD of 3 and 2? The LCD of 3 and 2 is 6, right? So I need to make one the LCD and the other the opposite of the LCD. Alright, so the top equation I'll multiply by 2, and then the second equation I'll multiply by -3. Alright, why did I pick these numbers? I want to make this 6, so if I multiply this by 2 I'll get 6. And I want to make this the opposite of the LCD, which is -6, so I multiply it by -3. Alright, so upon distribution of this values here to each both equation, I'll have 6x plus 4y equals 6, and -6x minus 3y equals -12. Alright, so I'll add down. You notice I've created opposites here, which is our intention because opposites cancel out to 0, and then here you're going to have y equals -6. And there goes your final answer, which is A. Okay? Alright, moving along. Let's take a look at number 5. It says, which of the following quadratic functions does not have -15 and 6 as zeros? Okay? So in order for a value to be a 0 of a quadratic function, when you input those values or those zeros into the function, you're going to get 0. If you get anything other than 0, then it's not. Alright, so one of these choices is not going to give us 0. Alright, so we can start with the first one or the last one. I'm going to go first, last, and then we're just going to telescope. Okay, so I'll try A first, and then D, and then B, and then C. It doesn't matter the order you do it. Okay, I just want to use that pattern. All right, so let's start with A. If I plug in these two into this function, I get 0, then it's good. If I don't get 0, then that's the answer. All right, hopefully we did it correctly. So for the test A, we're going to plug in, we're going to do f of -15 first. Let's do f of -15. What on earth does that mean? F of -15 means that you're going to plug in -15 for all the x's here, right? We have 1/3 times -15 squared plus 3 times -15 minus 30. If you get 0, that's good. Okay, so this becomes 1/3 times 225 minus 45 minus 30. A third of 225 is 75 minus 75, which equals 0, which is good. Next thing we need to do is f of 6. We have to plug in both of them into the function, and then we're going from there, right? So f of 6 is 1/3. Plug in 6's for all the x's times 6 squared plus 3 times 6 minus 30. So you're going to have 1/3 times 36 plus 3 times 6 is 18 minus 30. A third of 36 is 12 plus 18 minus 30. And then you're going to have 30 minus 30, which is 0. works. So A is good. So the zeros of this function is negative 15 and 6. Alright, so A checks out. So let's go ahead and test D. If it doesn't work, we just keep doing everything. One of them is going to fail eventually. So let's test D. So for D, I'm going to do f of 15 first. So for that, I'm going to do negative 15 square minus 9 times 15. 9 times negative 15 minus 90. What did I just do? I just took, this is my new f, okay? So let me just write it down so we don't get confused. For D, f of x is negative x squared minus 9x minus 90. That's what I'm using for D. For A, I use 1/3 x squared plus 3x minus 30. Alright, so let's work this out. We're going to have negative 225 plus 150, plus 135 minus 90. Okay? And then when you work this out, you're going to get negative 180. Negative 180 is definitely not 0. So that shows that negative 15 is not a 0 to this function. Hence, this is our answer. Our answer is D. Okay? Alright. Now let's move on to the next example. Question number 6. It says, the base of a triangle is 3 inches less than twice its height. The area of a triangle is 126 square inches. Which of the following equations can be used to find the height, to find h, the height of the triangle in inches? So for this one, one cool thing we can do is we can make a sketch of a triangle. So let me just sketch a triangle right here. So we have a triangle, there goes the base, and then there goes the height, h. Okay, it's B. Now, what is the formula for the area of a triangle? The area of a triangle is basically 1/2 base times height, right? But the base is described as being 3 inches less than twice the height. So B is basically 2h minus 3. So 3 inches less than twice the height. So I'm going to plug in these values for the area in area formula. Also, I know that the area is 126. So basically, A is 126. H is h because we're finding, we want to write equation in terms of h. If you look at all these options right here, they're all in terms of h. So let's keep h. But b has to be gone because these equations do not have b in them. B is expressed in terms of h, and how do we do that? We just use these hints. 3 inches less than twice the height. So express b in terms of h. And to express h in terms of b. So we're going to have b equals 2h minus 3. Alright, so I'm going to plug in these 3 values into this equation, solve it for h, and that should tell me what the answer is. Alright, so I'm going to have a is 126 equals 1/2. The base is 2h minus 3, and the height is h. Okay, now I can multiply both sides by 2 to get rid of this 1/2 right here. So I times this equation by 2 over 1, and then this one by 2 over 1. Alright, so this 2 cancels out with that 2. And then we're going to have 252 equals 2h squared minus 3h. Alright, so we need to set it equal to 0. So all we just simply do is subtract 252 from both sides. And then our final result is going to be 2h squared minus 3h minus 252 equals 0. Alright, and our answer is D. Alright, let's move along to the next question. Question number 7. It says the table below shows ordered pairs that satisfies the quadratic function f. Based on the table, the solution to the equation f of x equals 0 is found in which interval? So, if you want to find a solution, that happens where the y value, the output switches from positive to negative, or from negative to positive. Okay, so let's write down a side note. Take this out. Alright, so solution happens Just a side note, so solution exists where f of x switches from negative to positive or from positive to negative. Alright, so in this case, negative to positive basically means that you have a situation where you're going down, up, okay? There's a function. If you're down, it was negative, here it's positive. So exactly at this x value, you have a solution. Positive to negative is a case where you're decreasing, you're going down. It was positive before, f of x, and it is negative here. And then that x value right there tells you where your solution is, okay? So all we just need to do is focus on the output and look out for a sign change, okay? So if you take a look at the output, you have a positive here, positive, 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 and then it switches to negative, 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 negative. So it's basically like this case right here. It's a decreasing function, so to speak. So where the sign switches, which is over here, from negative to positive, that is where the solution is, alright? So where it switches from here to here, these x values basically tell you where the solution is. So the solution can be found on interval 1 less than x and x is less than 2. Alright, so your answer to this one is C. Alright, let's move on to the next example. Question number 8. So it says, which figure best describes the graph? Alright, so for this one, we are going to employ our knowledge of conic sections. Alright, so remember, when you have conic sections, if you have just one square, one of the variables squared, so one square, that automatically makes it a parabola. Okay? In this case, we have two squares, so you have a square here and a square here. But if you have just one square, let's say one of these are missing, you have a parabola. Okay? If you have two squares, basically you have x squared and the y squared. In that case, it's either going to be an ellipse, a circle, or a hyperbola. So in this problem, since we have two squares, parabola is not an option. We can eliminate that. Now, if you have two squares and they're separated by a plus, and the coefficients are different, you have an ellipse. Okay, ellipse is you have a plus in between the squares. The coefficients are different. For a circle, you have a plus in between the squares, and the coefficients are the same. And you have a circle. Circle and ellipses are very similar. The circle is a special case of an ellipse because you go equal directions in all directions from the center. Alright, so coefficient is the same. You have circle with a plus. Well, coefficient is different with a plus. You have an ellipse. Hyperbola is just simply when you have a minus between the squares. Alright, so take a look at this square and take a look at this square. What sign is in between them? You have a plus. So since you have a plus, it's either an ellipse or a circle. If this were a minus, it will automatically become a hyperbola. So since this sign right here is a plus, this is gone. Alright, so let's see. Coefficient is different. Ellipse, coefficient is the same hyperbola. Coefficient is the same circle. So let's look at this. What are the coefficients of the squares? 2 and 5. Are they the same? No, they're different. Since you have a plus, the coefficients are different, and two squares, your ellipse is, your equation is that of an ellipse. Alright? If this were 2 and that were 2 also, we'll make it a circle. Alright? So the answer to this question is B. Alright. Now, let's move along to the next question. Question number 9. It says the graph of the quadratic function f is shown in the grid below. If the graph f is translated 5 units to the right and 4 units down to create a new graph, which function best represents the graph? Now, first of all, let's look at the opening of this graph. It opens down, this is a STAAR parabola that we have right here. Okay, take this out. Just bear with me for a minute. So this one opens down. So if you have if we have a parabola that opens down, the equation basically starts with a minus. So you have a minus ax minus h squared plus b. All right, plus k. Sorry, plus k. So if you have a minus, if you have a SAT parabola, put some i's there for you. If you have a SAT parabola, you have a minus first, okay? But if you are opening upwards like this is a happy parabola. Just have to see the i's there. Happy. In that case, you have y equals ax minus h squared plus k. Now, if you look at this, these ones do not have any minuses in front of them, so it cannot be C and it cannot be B, since this is a SAT parabola, so it's either A or B. So how do we know which one is correct? Well, all I'm going to do is I just simply move the vertex, because these equations are generated using the vertex, right? So I'm going to move this vertex. This vertex right here is 3, negative 2. I'm going to move it 5 units to the right. 1, 2, 3, 4, 5. And I'm going to move it down 4 units. 1, 2, 3, 4. So that gives you the new vertex of your parabola. So it's going to open downwards like this. So what really matters is the equation of the vertex, right? Is the coordinates of the vertex right here. So what are the coordinates here? The coordinates here are 3 and negative 1. Alright, so if I want to plug it into the equation, the standard equation is basically y equals negative ax minus h squared plus k. So if I plug this in here, what I'll do is I'm going to go since this 1 here is going to be negative x. Now for the x coordinate, you take the opposite of this sign, minus 3. And then for the y coordinates, you don't take the opposite, you just keep this sign, minus 1. Alright? So which one matches? The answer is B. Alright? So don't forget, you take the opposite of the x for the x coordinate, and for the y coordinate, you just leave it alone if you use it, writing it in this formulation. Alright, let's move on to the next example. Question 10. It says, what is the solution? What value of p is a solution to the equation below? So if I wanted to solve this, 8 root p minus 1 equals 3. To do this, all I just have to do is get p by itself. So I just need to get rid of 1 first, 8, and then the square root. So to get rid of 1, I add 1 to both sides. And then I'll have 8 root p equals 4. Divide both sides by 8. And then you have square root of p equals 4 over 8. 4 over 8 if I divide it by 2, top and bottom. Square root of p is basically going to be, well, I could divide by 4, right? Let's divide by the LC. Just divide by 4, top and bottom. So you're going to have 1 over 2. Alright, to finally get p by itself, I need to do the opposite of square root, which is square. So I square this, and I square that, and then I'll have p equals 1 squared over 2 squared. Square the top and the bottom, which is 1 over 4. So the answer p in this case is equal to 1 over 4. Okay? Alright, now let's move on to the next example. Question number 11. It says the formula p equals 2 pi L, with L over 32 can be used to approximate the period of a pendulum, where L is the pendulum's length in feet and p is the pendulum's period in seconds. If a pendulum's period is 1.6 seconds, which of the following is the closest length of pendulum? So for this problem, I'm going to use, since we're approximating, I'm going to use pi. I'm going to use 3 for pi. Okay, so we know that pi is 3.14 and it goes on and on. But let's just use pi as approximately 3 for the sake of approximation here, okay? And then we can then figure out what the answer is based on what we have. So I'm going to have, I know pi is 3, and then the pendulum's period P is 1.6, and L is what we're looking for. Alright, so I'm going to plug in these values into my equation and then try and solve for L. Alright, so I have P equals 2 pi times the square root of L over 32. For P, I'm going to put 1.6 equals 2. For pi, I'm going to use approximate value, which is 3, times the square root of L over 32. When I get L by itself, that should be my answer, right? So I'm going to have 1.6, 2 times 3 is 6, 6 times the square root of L over 32. So I can times both sides by the reciprocal of 6, which is 1 over 6. So times this by 1 over 6, and times this by 1 over 6 also. The reason I'm timesing it by 1 over 6 is I want to get rid of this 6 right here, so we can get L by itself. Alright, so this 6 and that 6 cancels out. So I'm going to have 1.6 over 6 equals the square root of L over 32. Now, one thing I can do is I can make these two into whole numbers. So I put the 6 down here. I put a decimal point next to the 6. So to clear the decimals here, I can times the top and bottom by 10. Okay? Because if I move this, if I times this by 10 and times it by 10, this is 1, 0. The decimal point is going to move one place to the right on the top and one place to the right on the bottom. So it's basically going to become, let me split my workspace in half. It's going to become 16 over 60. 16 over 60 is the same thing as 1.6 over 6, alright? And that equals the square root of L over 32. On earth did that become 36? I don't know. Let me fix that real quick. Sorry about this. It's supposed to be L over 32. Alright, 16 over 40. Let's reduce this. 16 over 40. What goes? 16 times 5. Well, that doesn't work. Let me divide by 4, okay? So 4 goes here 4 times, and 4 goes into 60 15 times. Alright? So we have that. Now advancing, let's see, we have 4 goes in 4, 4 goes in. Okay? Alright. Now this equals the square root of L over 32. Now to get rid of the square root, we're just going to square both sides. So I square this, and then I square that. So I'm going to be left with, on the top, 16 divided by 225 equals L over 32. And then to get, alright, so we're just going to cross multiply here to get the L by itself. So actually, we don't need to cross multiply, just multiply both sides by 32. So times this by 32, and this side by 32. Okay, and then you notice this cancels out, and then we're going to have L, change the color, L equals 32 times 16 over 225. Alright, so what is 32 times 16? We can do that over here. 32 times 16. So I have 6 times 2. 12, 2 carry 1. And then 6 times 3, 18. Plus 1, 17. And then 1 times 2, 2. And then 1 times 3, 3. Alright? And then we add it up. We have 2. 7 plus 2, 9. 1 plus 3, 4. 492. Alright? So we're going to have L equals 492 divided by 225. Alright, so just divide this and then we're going to get our answer, right? So what is 492 divided by 225? So let's do that over here. Erase this so we don't get confused. We'll have 225 divided by 492. Let's try 2 first to see if that works. So 2 times 225 is 450. Alright, and then subtract that, and then you have 4, 2. And you're going to have a decimal, some decimal, but if you look at the options here, the only one that has a 2 is a C, so your answer is automatically C. Alright? Alright, let's move on to the next example. Question number 12. It says a chemical's compound concentration in milligrams per liter during a reaction can be modeled by the function below, where T represents the number of seconds that have elapsed during the reaction. In this situation, what are the domain and range for this function? So the domain is basically the constraints on the input or the independent, and then the range is the output. Alright, so let's do the input first. Since we're looking at what happens T seconds after, we're going to be starting from 0 and we're going to be increasing. We know that time is always positive, so whenever you're calculating time, it always moves forward. Alright, so time elapsed is going to be basically what happens on the clock. So for the domain is going to be on the independent variable, which is t. So when you start from 0 and it keeps going on and on, that means t is going to be greater than or equal to 0. Alright, so that's what your domain is, because t starts from 0 and then it's positive and keeps going on and on forever. So like you have a number line, you start from 0, the time starts from 0 and keeps moving forward forever. Alright, so t goes on all the way to infinity. Now how do we find what the range is? To get the range, all you just simply do is you just plug in the minimum value for the domain and the maximum value for the domain, hopefully. And then that will help us find out what's the range is. So the minimum value for this function is 0. So t equals 0 because that's where you're starting from. So I'm going to plug in f of 0 into my function. So f of 0 is going to be 100 divided by 0 squared plus 1. Alright? So when I plug that in, this is the minimum domain. I'm going to end up with 100 over 1, which is 100. So that tells you one of the extremes. And then to get the other extreme, I'm going to plug in what the maximum value is. Since t goes on forever, we're going to use t equals infinity. Alright? Infinity is basically a really, really big number. Alright? Since it goes on and on forever towards infinity. So what happens when you plug in infinity into this function, f of infinity? Well, you're just going to have 100 over infinity squared plus 1. Infinity squared plus 1 is a really, really big number, so you're just going to have 100 divided by infinity. So if you divide 100 into infinitely small itsy-bitsy pieces, what size will each piece be? If you divide 100 into infinitely many pieces, guess what? Each side will be so small that you can't see it. So 100 divided by infinity is simply 0. Alright? So basically our range is going to be going from 0 all the way to 100. So our range is going to be on the dependent variable, which is f of t, is going to be from the smallest 0 as less than f of t, and f of t is less than or equal to 100. Alright, so these two combinations will give us what our answer is. So the answer to this problem is A. Alright, now let's move on to the next question, question number 13. Question 13 says, a monthly cell phone plan charges $5 for the first 300 text messages used and 15 cents for each additional message. On this plan, what is the number of text messages that must be used in order to make the average cost 5 cents per message? Alright, so let's say because in this case you have 300 text messages, standard first, and then you have X additional. You have additional messages after 300. So I'm going to make a declaration here. Let's call the additional messages that you created. Let's call them X. Okay. So I'm going to make a declaration here. Let X equals the additional messages. All right. So the total number of messages you're going to have, so total messages in all is going to be your standard 300 plus the X messages. All right. So if you want your average cost to be 0.5 cents, I mean 0.05 dollars or 5 cents per text, that means that we multiply this by that'll give you a total cost. So total cost is basically going to be your standard 300 plus the additional X multiplied by 0.05. All right. Now, if we take a look at what the cell phone plan suggests, it says $5 is for the first 300 and 0.5 for each additional. And each additional, remember, is going to be X. So if this is a total cost, using the pricing plan right here, we're going to have $5. The total cost is can also be written as the original $5 plus 15 cents per additional message. So 0.15 times each additional message was each additional message is X, right? So like that. So these two have to be the same in order for your average cost to be 0.05 cents. So all I just have to do is I have to set up the equation. 5 plus 0.15x equals 300 plus x times 0.05. So when I solve this equation, it will basically tell me what I need to find. All right. So I can distribute this to both sides. So I have 5 plus 0.15x equals 300 times 0.05. We can multiply that out. 300 times 0.05. Let's do that. So I just go 300 times 5, 15. I have two decimal places. So it's going to be 15 plus, when I distribute 0.05 to x, 0.05x. Okay? Now, to make this quicker to do, I can eliminate the decimals by multiplying both sides of my equation by 100. Okay? So if I multiply both sides of my equation, why did I pick 100? Because I have two decimal places. If I want to shift this decimal place 1, 2, I'm going to have a 0 here and a 0 here. And what decimal place has 2 zeros? It's 100, right? So 2 here and 2 here. If I move 2 here and I move 2 here, then I'm guaranteed that all the decimal points will be gone. So it will be easy to solve the problem. So what I'm going to do is multiply both sides of my equation by 100, all right? So the left side, multiply by 100, and then the right side multiply by 100. This clears out the decimals so I can work with ease, okay? So on the left side, I'm going to have 500, and then 0.15 times 100 is just plus 15. X equals 1500 when I multiply 100 times 15 plus 5x. Alright, now what I'll do next is I will subtract 5x from both sides, subtract 5x, subtract 5x. And I can subtract 500 also, so I can get all the x's on one side and all the numbers on the other side. So subtract 500, subtract 500. and then you have 10x equals 1000, and to get x by itself, divide both sides by 10, and then you have x equals 100. Alright, so this is the additional messages. So the total number of messages that we need, so total messages, remember, is 300 plus x. So total messages is gonna be 100 plus 300, which is 400. So there goes your answer. Your answer is A. Okay. All right. Let's move on to question number 14. Question 14. It says, which function is the inverse of f of x equals 2 to the x plus 1? So when you're computing inverse, what you do is, it's easier to express y as f of x, or f of x as y. So I'm going to rewrite this function as y equals 2 to the x plus 1. So when you're looking for inverse, it's just like the question we did earlier. What number was that? Number, can't remember the number. Yeah, anyway, the problem we did earlier, question number 2, remember we had to switch. We had to switch the x and the y. So that's exactly what we're going to do here. We're going to switch the x and the y's, and then when I solve for the new y, that will be my result. Alright, so for this one, I'm going to switch the x and the y's here. Alright, so switch x and y's. So I'm going to have x equals 2 to the y plus 1. So let's get y by itself, right? So to do that, I'll subtract 1 from both sides. I'll have x minus 1 equals 2 to the y. Alright, so to get rid of this this exponent right here, I'm going to use the opposite of exponent, which is log. Since we have a 2 right here, that's going to be the basis of my logarithm. Okay, so what I'm going to do on the left side, I'm going to have log base 2. I chose 2 because this is the base of the exponent here, of the quantity x minus 1 equals log base 2 of 2 to the y. Alright, the reason why I chose log base 2 is because log base 2 and 2 are opposites. I mean, log base 2 and the exponents 2 right here are opposites, and they basically cancel out. So this and this cancel out. So you're going to be left with y. Let me write that. Y equals log base 2 of x minus 1. Okay? So your answer is basically A. Alright. So thanks so much for paying attention to this presentation. Please subscribe to my videos here and like, comment if you liked it. And the collection of my clips can be found on mathgotserved.com. So thanks for paying attention to this again, and have a wonderful day.